And welcome back, students. We are going to continue talking about static methods and static variables. Specifically, last time we talked about static methods, so today we'll discuss static variables. So with a static variable, the first thing you need to know is that a class can have static variables as well as static methods. You don't have to be exclusively locked to one or the other. A static variable is a variable that belongs to the class as a whole and not just to one object. So it's not necessarily a property of the object, it's more of a property of the class. Each object has its own copies of the instance variables. However, with a static variable, there's only one copy of the variable, and all the objects can use this one variable. Thus, a static object can be used by objects to communicate between the objects. So I'm going to go real quick here back to our very primitive early example of an object. And remember, we talked about an object like a box. It has length, width, and height as properties. And here, what this is saying, normally when we create an object, each object has its own length, width, and height. However, when we are looking at a static, there's always going to be a shared property between them. So, for example, let's say we want to calculate the volume of a sphere. Well, no matter what, we know with the sphere, we're always going to need to use pi. Pi is never going to change in value, so therefore we could use a static value set to that constant value. That's just one quick, easy way. Or if we go back to our length with the height example, let's say we have a series of boxes and they're all sharing the common height, because we don't want boxes to be any more than, let's say, 24 inches. All right, so we all got to fit inside a 24-inch frame, so we can make them of various widths and lengths, but we don't want them taller than 24 inches, so we could use that as a commonly shared static variable. Now, typically with one object has the ability to change that static variable, and then another object can come along and then read that change. Right? So it's not that the variable is unchanging, but it's a common one that's shared. All right? So if we said, hey, going back to the example of the box is 24 inches, then we say, hey, we just got an upgrade. We can now fit boxes up to 36 inches. So it's now a 3-foot clearance. So we can go in and change that later. It's not that we can't change it. We'll talk about that later on, but it's just that we have to share that between those different objects. So continue to talk about static variables. In order to make a variable be static, we declare it like any other instance variable, but we would add the modifier static. So private static int turn. Or if you wish to initialize a static variable, we can declare similarly as this example shows. Private static int turn, well, this should be int, equals 0. Now, one thing to note with a private variable, the default initialization. If we do not initialize a static variable, it is automatically initialized to a default value. Booleans are automatically initialized to false. Static variables of other primitive types, such as char, int, long, short, all that, are initialized to the respective 0 value. Static variables of a class type are automatically initialized to null. Now, what null means, don't worry about it at this point. You can kind of just think of it as having no value, but we will discuss what null means later on in this chapter. Now, it is preferred to explicitly initialize static variables as shown either previously or with a constructor. So you can either just give it a hard set value, or you can use a constructor method in order to give it a value. Now, the default initialization, I have this turn taker class in the materials, which shows a class of the static variable along with the demo program. It says, notice that the two objects, lever 1 and lever 2, access the same static variable. So if I go over to here, and here's my turn taker, and then in here we have private static int turn, right, and set to 0. Right. The two objects, lever 1 and lever 2, are found here in the static demo class, and you'll see that right here are two objects, and they're both initializing turn. Right. As already noted, you cannot directly access an instance variable within the definition of a static method. However, it's perfectly legal to access a static variable within a static method because the static variable belongs to the class as a whole. This is illustrated by the getTurn method. So if I look at the getTurn method, which is down, right? So it is my turn. Get name, getTurn right here. So public static int getTurn, turn plus plus, return turn. All it does is increment turn and gives you the value back. Right? So if we say, if we were to call getTurn, it would do just that. Now, when we write turn in the definition of the static method getTurn, it does not mean this dot turn. So if I'm looking back here, all right, this turn is not necessarily referring to this turn. Okay. Instead, we're referring to turn taker dot turn. So I'm referring to it as an instance of the class, not of the object. Even though, yes, it is still referring to this instance variable, when we start talking about with it being a static, it's no longer belonging to the object. So it doesn't, turn does not belong to the two objects, level 1, level 2. Instead, turn is going to belong to the class. So that's why we use turn taker dot turn. If the static method variable turn were marked public instead of private, it'd be legal to use turn taker dot turn outside the definition of the class turn taker. So some defined constants also. Defined constants are ones that we've already been using, are a special kind of static variable, such as public static final double pi equals 3.14159. We've already been using those. So here's a quick example that we used this before when we started talking about the round demo. Now the modifier final in the example means that the static variable pi cannot be changed. Remember I talked about before we can change static variables, we can read static variables. Well, if you add in the word final, it means you cannot change that variable definition. Final just means that it's final. No more changes can be done to it, cannot be modified. You cannot change it. You can read it all you want. So you can still access that value, but you can't change it. Now, such defined constants are normally public and can be used outside of the class. And the reason why you want to be public, because if they were private and they're final, you really can't do too much with it really outside of it. So that's why we generally make it public. Now, this defined constant, as I already mentioned, appears in the class round stuff. And to use this constant outside of the class, we'd write the constant in form of the stuff, round stuff dot pi. Similarly, like if we looked before, when we had this page here, we had turn taker dot turn. Here you'll see we use round stuff dot pi. So you always, it's the name of the class dot whatever variable you're calling. Now, a little bit to note with programming style. Programming style dictates that static variables should normally be marked as private, unless they're marked final. That is, unless they're defined as constants. If you notice, when we just turn the rail back here fast to this one, you'll notice public static final double pi is a constant. Right? Pi is a constant. It's one fixed value. We're not going to be changing it from anything. Right? So if you have a final, it's going to be a constant generally. The reason is the same reason now for making instance variables private. Remember, if you remember, we said with instance variables being private, we don't want them being accessed outside of their class because we don't want it to be influences that we want them to be objects of that class. This is the same thing here that we have going on with our static variables. So we want them to be private unless they're marked final. Now, another quick example of a static variable is the class invocation counter in the course materials. The static variable number of invocations is used to keep track of how many invocations have been made by all objects of the class static demo. The program then counts all invocations of the methods defined in the class except for the main method. All right, so that's the end of the notes, but let me just go ahead and take you over here to the invocation counter. And you can see in here, here's my static right here, number of invocations. I initialize it to 0. Then I have my demo method, which is just takes number of invocations plus plus, public void output count, number of invocations plus plus, print line, number of invocations so far equals number of invocations. Public static int number so far, number of invocations plus plus, return number of invocations. And then in here, here's a main method inside of this class, and it says int I invocation object counter equals new invocation counter. For I is 1, I is less than or equal to 5, I plus plus, object 1.demo method, so then it calls this method up here, number of invocations. then it outputs this, and then it's going to go ahead and do object1.put count, invocation counter, object2, new invocation counter, for I equals 1, I less than or equal to 5, I plus plus, object2 to demo method, object2 to output count, number of invocations equals number so far. So if I run this, you can see that we will end up with, just stretch it up a little bit, you get the number of invocations so far. Number of invocations so far is 8, number of invocations are 10, 12, 14, 16, and 17. Now if I just go ahead and just add in here real quick, this will not be in there, but just to show you the break between these in case you're wondering where that might be. I'm just going to put test. Just so you can see where that would be if I run this. All right, so right here is test, and the difference between the two of these is that this first loop right here does the entire iterations of it first, and then it outputs the count. Whereas this one right here, you'll notice that it runs the demo method, outputs the count, and does that each time. All right. Now you notice that these numbers are still going up, and the reason for that is because it's still iterating off of these here. Okay. Other than that, that's really all we have here, folks. So I'm just going to remove that out of there. So that concludes our notes for today, and I guess we will see you next time.